Volcanoes, towering giants of destruction and creation. For millennia, they've captivated humanity with their raw power and beauty. But beyond the spectacle, what's really happening when one of these mountains explodes? At the heart of any volcanic eruption is a story of intense pressure and heat. Volcanoes typically form where the Earth's tectonic plates meet and interact, but they can also arise at hotspots where plumes of magma push through the Earth's crust. Now, let's break down the anatomy of a volcano. Imagine this. Beneath the surface, there's a magma chamber, essentially a reservoir of molten rock. This is the source of everything that erupts. Above it is the vent, the pathway magma takes to reach the surface. And then, of course, we have the crater at the summit, the signature feature formed from past eruptions. Depending on the type of volcano, these features can vary a lot. There are three main types: shield volcanoes, stratovolcanoes, and cinder cones. First up, shield volcanoes, like Mauna Loa in Hawaii. These guys are broad with gentle slopes, and their eruptions tend to be less explosive, but the lava flows can cover massive areas. Then we've got the stratovolcanoes, known for their steep sides and highly explosive eruptions. Mount St. Helens is a famous example. And finally, the smallest type, cinder cone volcanoes. They may be small, but they can still pack a punch. Okay, so what makes some volcanoes more explosive than others? It all comes down to two key things: magma composition and gas. Magma varies in its silica content, and that affects how viscous or thick it is. Basaltic magma, which forms shield volcanoes, is low in silica and flows easily, but rhyolitic magma, which forms stratovolcanoes, is high in silica and super thick. This traps gas, building up pressure until, boom, you get an explosive eruption. The eruption itself is just the beginning. Volcanoes can cause widespread destruction, from lava flows that incinerate everything in their path to pyroclastic flows. Those are fast-moving clouds of gas and volcanic material that can reach temperatures over 1,000 degrees Celsius. History is full of tragic volcanic events. Take Mount Vesuvius in 79 AD. It buried the Roman cities of Pompeii and Herculaneum under ash, preserving them for centuries. But here's the thing: volcanoes also create. Over time, lava flows build new land, and volcanic soils are incredibly fertile. That's why so many people live near active volcanoes, despite the risks. In places like Hawaii and Indonesia, volcanic soil provides ideal conditions for agriculture, supporting entire communities. Volcanic eruptions don't just affect the local landscape, they can have global consequences too. When a volcano like Mount Pinatubo erupted in 1991, it sent so much ash and sulfur dioxide into the atmosphere that global temperatures dropped by half a degree for years. Mount Tambora's eruption in 1815 was even more extreme, causing what's known as the year without a summer, leading to worldwide crop failures. Fortunately, we're getting better at predicting volcanic eruptions. Volcanologists, scientists who study volcanoes, use tools like seismology, gas monitoring, and satellite imaging to predict eruptions and keep people safe. Seismic activity, or small earthquakes, often indicate that magma is moving beneath the surface. Rising gas emissions can signal an impending eruption, and by studying ground deformation, scientists can see a volcano swelling as it prepares to erupt.